Hey everybody, it's Mrs. Slauson, and we are going to be going over the Chapter 6 review if you need help. I don't have my cheat sheet in here, but I will be referring to it as I go through these. So I do need for you to pay attention to what parts would be without a calculator and what parts would be with the calculator. So we're going to start out with the non-calculator part. Just a reminder, you will need a calculator eventually, but you don't need it at this exact moment. So let's get started. Our first section that we're going to cover is graphing logs. So in order to graph a log, we're going to need to make that table, if you remember. Okay. And instead of putting values in for x, we put them in for y, just a reminder. And then to make the graph, I need to look at the base of the log because that will be the base of the exponent that I'm going to use. So I'll be making a table for 4 as a base, but I'll be putting my y values in to get my x values. So if you remember, anything to a 0 power is 1. 4 to the first power is 4, and 4 to the second power is 16. And if you feel like it, you could go ahead and make their fraction versions on the other side. So next thing I want to do is, what else is happening? There's nothing really else happening to this. It's just this. So that's all we would graph. This is just the very basic parent function. So when I think about the shape, since this base is bigger than 1, that's growth. And we have on our cheat sheet that growth looks like that lowercase r. So I just have to graph, 2 points, but I really have to know the shape since I'm only getting 2 points. So I'm going to graph 1, 0 and 4, 1. I'm going to remember that I have a vertical wall. It looks like a lowercase l. Okay. And then I'm going to make that lowercase r shape going through it. And then from there, I'm going to put in my arrows. So this is going right and up and nothing stopping it. This is going left, but it does get stopped at 0, but nothing will stop it from going down. So in all of our log problems, we will always have a restriction on the domain. It will be our wall, and then infinity, smallest x and biggest x. And then our range is from negative infinity to infinity always on this. And you can also write that all real numbers if you want. And just remember that you have a vertical asymptote, and this is it. And that's the equation of x equals 0. And the reason why it's x equals 0 is because every point on this asymptote, this wall, has an x value of 0. So for the next thing, I'm actually going to be using this as my table. So let's go ahead and just redo that. So -2, -1, 0, 1, and 2. My base is 4. So again, 4 to the y power is what we'll be using for our table. And it just copies this one. Okay. But here we have some additional things. So let's talk about the additional things. So this negative in front is going to cause a flip, and this 7 is in our house, and we always do opposite of that. So we're going to be going left 7. Okay? So when you think about the shape, right now that shape is this lowercase r, but that shape is going to flip so that when we're done, it's actually going to look like this instead. So let's go ahead and get our points on there. So here's 1, 0, but I'm going to move it left 7. And then 4, 1, but I'll move it left 7 as well. And then the other thing that's going to move left 7 is the wall. It's going to end up right here on -7. And I'm going to go ahead and draw. Oh, sorry, messed up. I hope you weren't doing all of that. This is me not paying attention. I forgot to put the flip in here, so I apologize for that. And I'm not going to restart the video. So the flip, would mean I take any stretch, compress, or flip, and I'm going to change my y value. So instead of negative, that becomes positive, positive, still a 0, negative, and negative. So these points are not correct. Let me fix that. I apologize. So 1, 0 is still correct, and it still moves here. But where 4, 1 was, it now flipped to 4, -1, and now it's going to go left 7 and end up here instead. So the x's, my apologies again, are going to be the point. So now I can draw that shape. Okay, and now it's matching the shape. So this arrow is going right and down, nothing stopping it. This is going to get stopped going left at -7, but nothing will stop it from going up. So we can put our infinities. So for our domain, we'll put our smallest -7 and our biggest infinity. And our range will be our smallest -infinity to infinity. Or you could just write all real numbers. And just remember, our vertical asymptote is at x equals -7 now, because every point on this wall has an x value of -7. So the next one we didn't graph in class. Well, I think we graphed once, but you should be able to handle this. So remember in LN that our base is an E, so I'm going to go ahead and make that table for you. And that's all we're going to graph here, is just the natural log of x. Here are those x values. And this time when we make our base, our exponent will be e base, and then to the y power to get our x values. And anything to a 0 power is 1, and e to the first power is about that 2.7, so close to 3. And the rest I'm not even going to worry about, because I wouldn't graph the fractions anyway, and I don't know what 2.7 to the second power is. I could do 3 to the second power and go a little bit lower than that, but this is fine. So this base is bigger than 1, so we're going to have the same shape as above. We're going to have that lowercase r for a growth shape. There's no stretch, compress, flip, left, right, up, down, so I'm just going to put 1, 0. And I'm going to go to about 3 and up 1. And I still have my wall here. Okay, so this is graphing the natural log of x. And so just like above, this arrow is going right and up with nothing stopping it. It is going to get stopped at 0 when it tries to go left, but it will keep going down because nothing's going to stop it. So my domain is 0 to infinity, smallest x and biggest x. And my range is -infinity to infinity. And again, you can always write all real numbers if you want. This is just a reminder on what intervals is f of x or y greater than 0. So the way you've seen that phrased is, where is it positive? So positive is where all my y values are positive. So down here my y values are negative, but once it gets here at 1, 0, it's not positive or negative, but after that it's positive. So we're going to put from 1 to infinity, and since I don't want to include 1 because 1 is not positive there, it's just 0, remember to use a parentheses. So on the next one, we're going to take the same shape, so we can keep the table. Nothing happens. I'm just going to move them down 4. So all of this is going to stay the same. Since it moves down 4, you're still going to have this shape. So where I'm at 1, 0, I'll just move down 4, 1, 2, 3, 4. And then where I was at about 3, 1, I'll move down 4. So 1, 2, 3, 4, and it ends up maybe right there. And then the wall is still where it was. Okay, and I'm still having that lowercase r shape. And it's still going right and up. It's still getting stopped at 0 and still going down. So my domain, just like the other one, is from 0 to infinity for the x's. And the range, this time I'll write all real numbers. So on this one, on what intervals is f of x less than 0? So they're asking when it's negative. Right now, it's kind of hard to see that. What we could do is, again, this is saying when y is less than 0. So here's a little bit of a challenge problem. Since I can't see it in here, I could actually figure it out mathematically. I'm going to put 0 in for y and for g of x and show you how you could solve that. So what I would do is try to isolate x. So this is the solving section, kind of one of those last topics we talked about. So I'm just going to add 4 to the other side and put my understood base of e here. And now to get to x, since it is a log, I would undo that log by making an exponent. And I'll make the base of the exponent e, so base this side e. And then I need the exponent, so this becomes the exponent and this becomes the exponent. And then what happens here is those will cancel out, and so when we're done, we get e to the 4th equals whatever what we need that x value to be. And then you can hit your second button with your ln. It builds in that exponent. So it's about 54.5. But what I would say, so somewhere here, way down the line at about 54.6, it eventually crosses over. So I could say from 50, so sorry, let me repeat that. It's negative all the way, because I'm looking for negative. I was thinking positive from the last one. It's negative until I get to here. So it's negative from 0 until I get to this 54 value, or this e to the 4th. So from 0, because we're using the x values, to e to the 4th, or you could put that 54.6. I think that was a bit of a challenge there. All right, so that is our graphing section. Let's move on to the evaluating part. So this part, again, is without a calculator, so please keep that in mind. So we've got these 6 functions at the top. Most of the numbers that you're going to have are in parentheses. The last 2 aren't, but we will worry about those when we get to that part. So based on this C, I want to go to C's function and put the 1 in right where that x is. And again, this is without a calculator. So what I need to figure out is 5 to the what power makes 1. Because remember, this is what I'm trying to solve for. I could put a little x there. And we showed you this e, make an e out of it. 5 to the what power makes 1. So this is essentially what I'm asking myself. 5 to the what power makes 1. And in this case, 0 powers make 1. So let's go to this one. I'm going to go to D's function and put 1/36 in for x. And here I'm going to ask myself 6 to the what power makes this fraction. Well, the fraction is done by a negative exponent, so that takes care of the 1 over. So now I just need to know 6 to the what power makes 36, and that's a -2. So on this one, we're going to put 2 functions together. We're going to go to R and put 6 in. And here there's not a base, so I'll put that understood 10. Okay, and then I'll go to T's function and put that in there. And I'll put that understood base here. And now we're actually going to simplify this. So what happens here is this 6 plus 4 is actually just 10. And I would ask myself here, 10 to the what power makes 10? This whole thing then becomes worth 1. And here I would ask myself, e to the what power makes all of this, e to the squared? So this is what I'm asking myself. E to the what power makes e squared? You could also remember that if the base of the log and the base of the exponent are the same, they cancel each other out. Either way, from all of this, you're going to get a 2. And then you can just add those 2 together, those 2 numbers together, that is, and you get a 3. All right, number 8, I'm going to go to C's function and put 125 in there. And then I'm going to go to D's function and put 36 in there. And I noticed this time I'm putting them in parentheses when I didn't put them in parentheses here. Sometimes I put the argument in parentheses, sometimes I don't. So I'm asking myself 5 to the what power makes 125, and that is a 3. And then here I'm asking myself 6 to the what power makes 36, and that's a 2. And then I'll just have to subtract those to get my final answer of 1. So the next 2 bring in composite functions and something that's just being reviewed from another chapter. This is a composite function, so based on this, I should start with these outer parentheses. So I'm going to take c of x, right, and write it down first. So here's c of x, and this says I should take c of x, whoops, sorry, can't even see that, and this should go in h of x's function. So I'm going to start writing h of x's function 5, but this says the c of x, so this is c of x, should go right where that x is, okay? So when I do that, let's see, hold on, it's going to go as an exponent, okay? And then this whole thing is to realize that the base of the exponent and the base of the log can cancel each other out, and when you're done, you just get x. So before I go to the next problem, let me just show you a different way you could have looked like that. So I could write h here and then c of x, which is this, and just replace c of x with what it's worth, right? So this is kind of a little bit longer of a step. And then this says go to h's function, which is here, and put all of this in for x, which is what I ended up doing, because I kind of jumped a big step. So there we go. All right, so for this one, I'm going to write the c, and then I'm going to put h of x's function in place of h of x. So that's going to be in parentheses, because I have these parentheses here, 5 to the x. And this says now go to c's function, and where there's an x, put this in there. So I'm going to do that next. And this is just a reminder that when the base of the log and the base of the exponent are the same, they can cancel out and you get x. So that part's reviewed, but the next part is just something to remind you of. Given what you found in 9 and 10, are h of x and c of x inverses of each other? So back, I think it was chapter 3, you were first introduced to inverses. And it's if you take composition functions, so if you take one function and put them in another, like this, and they have to be the same function, so c is going into h or h is going into c, and you get x, once you simplify it, then you know they're inverses of each other. So are they inverses of each other? Yes, they are. And how do you know? Because we simplified this and this, and when we're done, we got x on both of them. So just a little side note there. So the next two, if you notice, we are skipping 11 and 12. I took those out, and I did not want to remember all of them. This time we're going to solve. So I just want to remind you again, this is back from like chapter 1 or chapter 2, that not everything goes where the x goes. Here you're getting c of x. So here I'm telling you that c of x is worth 2. So going up here, this is worth 2. So that's what I'm going to write. 2 equals, and then the other side. And here we are solving. So that's where I told you, we'll just work backwards, most likely, usually, to solve for the order of operations, or to solve for x. And so I want to get it so it's just the log, so that I can make an exponent out of it. And as it turns out, this is all part of the log. So there is no addition, subtraction, or multiplication, division to get rid of. Instead, to undo the log, I'm going to make an exponent. And the base of the log tells me the base of the exponent. So making two bases of 5, one on the left side of the equal sign, one on the right side, and then this becomes the exponent, and this becomes the exponent. And just like what we talked about in problem 9 and 10, is that this base 5 and this base 5 can cancel out, and so that just becomes worth 5 to the second power, so x is worth 25. Nice simple number. So for this one, we're going to do the same thing. We're going to go to r of x, and this says that r of x is 0. So I'm actually going to go here and put 0 in there. And right now there's not a base, so I'll put that understood 10 when it's the word log. And so now I'm going to solve the same way. So I'd like to work backwards in my order of operations so that I can get to just the log. But this is just the log, so there's none of this or this to move. We'll just want to undo the log by making an exponent, and we'll make that exponent by making a base of 10 on the left side and the right side. And then this becomes an exponent, and this becomes an exponent. And then the base 10s can cancel out. On the right side, I'm left with x plus 4. On the left side, 10, or anything to a 0 power, is 1. And now to solve for x, excuse me, I'll just subtract the 4 over, and I get negative 3. So that is 13 and 14. I'm going to stop this video now and make a second video for the second page.